Okay, so let's take a look at what makes a problem a binomial distribution type question. So there are 4 requirements that need to be met in order for a question to be considered a binomial distribution. Let's take a look at this example right here, and I'll explain why this can be considered a binomial distribution type question. Okay? So the situation is a coin is tossed 3 times. What is the probability of getting at least 2 tails? So first of all, let's say we define x as tossing the coin and getting tails. Okay, so the question is we're trying to find what's the probability that x, so at least 2 tails, is greater than or equal to 2. So that's the question we're trying to answer. Okay, now without using binomial distribution, you can just answer this question by making a tree diagram, like we see to the left here. So if we want to find out when will x be greater than or equal to 2, so when will we have at least 2 tails? So that means 2 tails, or more, or it could be all 3 tails, right? So basically our answer would be, well, when do we have 2 tails? Here's 3 tails here, 2 tails. I see 2 tails here, only 1 tail, 2 tails here, 1 tail, and then all heads. So it looks like the correct answer to this, without even using binomial distribution, would be, well, we have 4 ways to get at least 2 tails, and then there's 8 possible outcomes. So the answer would be 1/2. Okay? Now, you can also do this problem using binomial distribution. Okay? But first you would have to recognize, okay, that this is a binomial distribution. So the first requirement, there are only 2 possible results in each trial, success or failure. So if x is defined as getting tails, well, basically there's only 2 things that can happen based on our definition. Either we flip the coin and we get tails, or we flip the coin Okay, so why is this question considered a binomial distribution? Well, the first requirement, if x is defined as getting tails, so if we flip the coin, we either get tails, which is considered success, or we don't get tails. It's considered failure. We did not get tails. So it meets the first requirement. The second, the trials are independent, meaning whatever happens the first time does not affect the probability of the second event. So when we flip the coin the first time, whatever happens, it doesn't affect the probabilities when we flip the coin the second or third time. So it meets the second requirement, the probabilities, the trials are independent. 3, there's a fixed number of trials. This question says we are going to toss the coin 3 times, so that would be considered the number of trials. And the fourth requirement, the probability of success for each trial does not change. Every time we flip the coin, the probability of getting tails is 1/2. That never changes with the other trials. So it meets the fourth requirement. Okay? So that's why this example here meets the 4 requirements for a binomial distribution. So if you were to do this question using binomial distribution, the first thing you should do is you should always define what your x means. Okay? So this is x, we're saying, well, it means getting tails, right? So getting tails. So whenever you're doing a binomial distribution question, define your variable, okay? And then we want to say that, okay, x is binomially distributed, and this is the notation we would use. So this means that you recognize this is a binomial distribution, and our parameters are, so the first number here is going to represent the number of trials. In this case, it'll be 3, right? There are 3 number of trials. And then the second value here is the probability of getting, that x value, right? So what's the probability of getting, tails? In this case, it's 1/2, or 0.5, or you could put 1/2 there. It's up to you. Okay, so this represents the number of trials, and this value represents the probability, of success. Okay, So you want to represent, you want to state this right here, okay? So that whoever's grading the test, they understand that you recognize this is a binomial distribution question, right? Because that would be the method mark, okay? So now we're gonna do this using binomial distribution, basically on the calculator. Oops, on the calculator, all we have to do. Let me erase this real quick. Let me pull up the calculator. So let me move this a little bit. So we would go to menu, all right, statistics, distributions. Now we're trying to find the probability that x is greater than or equal to. So we're going to use binomial CDF. Binomial CDF is used anytime you have an inequality, okay? So number of trials, we have 3, probability of success, right, 0.5, right? Lower bound, this is the lowest value x can be. So remember, we were finding what's the probability x is greater than or equal to 2. So the smallest value x can be is 2. What's the upper bound? This is the highest value x can be. Well, there's only 3 trials, so the highest x can be is 3, right? We can get all 3 tails, right? Click OK, right? And then we have this, 0.5, same answer as last time, okay? Now, if you're doing this using the GDC, you should always make sure you, all right, write this out so that the person grading it knows what you did, right? So over here, I would put binomial CDF, and then we had 3, 0.5, lower bound, upper bound, and then our answer was 0.5. Okay? So if we can do this problem without binomial distribution, so why would we do it with binomial distribution? So this question, you probably don't need binomial distribution. But imagine, what if there's a question, right, where if you tossed a coin, instead of 3 times, you tossed it 50 times, right? You're not going to make a tree diagram that's going to represent 50 tosses. So that's the purpose of binomial distribution. When you have questions where the number of trials is very large, you're not going to draw a really big tree diagram. It's much more efficient and easier to use binomial distribution. Okay? So let's take a look at this other example right here. So first of all, a fair die is rolled 10 times. What is the probability of getting the number 3 7 times? Okay? Now, first of all, you need to recognize, wait, when I'm reading this question, right, does it meet the 4 requirements for binomial distribution? So if we define x, in this case, right, x is going to be getting the number 3, all right? So getting the number 3 when we roll the die. So that's our definition for x. And we're trying to find what's the probability of getting 3, all right, 7 times. So what's the probability x will equal, all right, 7. Now, let's go through our 4 requirements. So 1, there are only 2 possible results. In this case, success would be considered getting the number 3, all right? And failure would be getting anything other than 3, right? 1, 2, 4, 5, 6, right? The trials are independent. So the probability of getting a 3, right? So the probability of getting 3, right, is 1 out of 6. This doesn't change. Every single time we, all right, roll the die, the probability of getting 3 is 1 out of 6, right? So it meets requirement 2. 3, there are a fixed number of trials. It says the die is going to be rolled 10 times. So that's our number of trials, right? And 4, the probability of success for each trial never changes. Every time we roll the die, the probability of getting 3 is 1 over 6. That never changes. So this question meets these 4 requirements, okay? So when you're reading the questions, if it sounds like it might be a binomial distribution question, think about these 4 requirements and make sure the question meets these 4 requirements. So we're trying to find out, all right, what's the probability of getting the number 3 7 times? So we've defined it. X is getting the number 3. We want to know when it will equal 7. So once you have this, you just put all the information into the calculator. So in this case here, we go to menu, all right, statistics, all right, distributions, all right, binomial PDF. Now when X is equal to a value, we use binomial PDF, not CDF. CDF is for, all right, so binomial CDF is for when you have inequalities, when X is greater than, all right, or less than some value. Whenever X is equal, we always use binomial PDF. So binomial PDF, number of trials, all right, is going to be 10. All right, probability of success, all right, each time we roll the die, the chances of getting a 3 is 1 out of 6. So you could just actually just put 1 divided by 6 here. It doesn't have to be a decimal. And the X value, we want to know, well, we want to get the number 3 7 times. X equals 7. Click OK. And we should type all this, and then there's our answer, right? So first of all, we want to show that we recognize this is a binomial distribution. So you should also say X is binomially distributed, right? Our parameters, there are 10 number of trials, and the probability of success is 1 out of 6. So make sure you write this here. This is important because this lets the grader know that you recognize it's a binomial distribution question. Next thing, you want to make sure you always write this also in the calculator. So we have binomial PDF, right? And then there are 10 trials, probability of success is 1 out of 6, and X equals 7, right? So there are 10 trials, probability of success was 1 out of 6, and X is equal to 7. And then our answer was, or our answer is, all right, 0.002481. So 0.000248. 81. Let me just double check that. Yep, 302481. And then that would be our answer. Okay? So whenever it's a binomial distribution type question, make sure you define, right, what X is. Make sure you state the parameters of your binomial distribution. Right? Whatever you put in the calculator, right? This is what we're trying to solve. Write out what you put in the calculator. So just in case you press some wrong number or something, the examiner, the person grading your test, sees all this information. Let's say this is a 4-mark question, right? You would get 3 marks because maybe you just press a wrong number or something, but they see everything else is correct, right? Just your final answer was wrong because you pressed the wrong number on a calculator or something. So make sure all this is written, right, on your test, okay?